Hello everyone, and this video is for English-speaking subscribers. I'm on a shuttle tanker and I will tell you about a complex malfunction in the controllable pitch propeller system. The tanker has two main engines and accordingly two CPP main thruster system. The previous crew said that a month ago an alarm CPP control failure occurred. Follow-up control from lever out of order, maneuvering control transferred to engine control room, but the problem remained. After that, the system was switched to emergency mode. In this mode, the pitch control performed by pressing the appropriate push button, and this can be seen on pitch indicator. Also, in emergency mode, the pitch can be changed from panel on the wheelhouse. Using the same push buttons, we can see the changing of the propeller pitch. After some time and the emergency mode was out of order and pitch control was immediately transferred to local mode. In this mode, one of the engine crew rotates a spatial control wheel to the desired angle by listening commands from the bridge using telephone communication. Now we are going down to the engine control room where I will show you how to transfer the system into local control mode. This is my first experience of translating a video in English. I apologize for the sound quality. The next video will be better. Now all videos on my channel will be in English, and old videos I will translate into English. Change the switch position from remote to local. By turning the wheel we can see how the angle of the propeller pitch changes. The previous crew was forced to work in this local mode with this unsolved problem all this time. So first of all, we need acquainted with the damage report. It says that due to a short circuit between signal and supply wires, the stepper motor driver burned out. This is electronic device that use a voltage signal to change the speed and direction of rotation of the stepper motor. The cause of short circuit was vibration. Wires frayed through and shorted, you can see it on photo. There was a driver in spare parts and the electrician replaced it, but the system in follow-up control mode didn't work. Alarm CPP control failure still occurred. The system transferred to emergency mode. After working for a couple of days, this driver fails and then continued to use the system in local mode, which I already talked about. Requisition for stepper motor, driver and electronic boards were made. I didn't want to leave the system in faulty state and try to restore the burned drivers, but unsuccessfully, because there were no suitable MOSFET transistors. Finally, the idea came up how to start the stepper motor in a different way. First, let's take a look at schematic diagram. 4 wires power supply to the stepper motor. In normal mode, when the driver board does not receive a control signal, the motor winding is supplied with a direct current in order to fixate the rotor with constant magnetic field, and it is no longer possible to rotate the shaft with the control wheel. Switch S1 is needed to remove power supply from the stepper driver board to unlock the shaft and thereby transfer the system to the local mode. Now, using the example of working driver board, I will show you how a stepper motor works. Accordingly, with the schematic diagram, supply 24 volts to the driver and connect 1.5 volts from battery to the signal wires. The motor shaft starts to rotate at a speed proportional to the voltage. If we change the polarity, the rotation will change. LEDs indicate the presence of an input signal. If apply a higher voltage 10 volts, the speed will increase. And this is how a faulty driver with broken transistor works. These two working drivers, on the example of which I showed the operation of the motor, I received at the end of this contract. But at that moment I decided to make a stepper motor driver myself. At first I designed and drew a simple electrical schematic with which it was possible to start the stepper motor from alternating current power supply. In the diagram we see a step-down transformer, which supply from 220 volts, phase shifting capacitor, which was difficult to calculate, and addition relay contacts, which change the direction of stepper motor rotation. The control circuit consists of optocouplers, to which a voltage signal of different polarities is applied depending on the direction of rotation we need. and this was seen in the example with batteries. And depending on the polarity of the voltage, the optocouplers control the transistors that supply power to the relay K1 and K2. The control circuit is powered by 24 volts. The result is the following electronic construction. Also, I needed some time to choose appropriate current limiting resistors to avoid overheating electronic components. The main disadvantage of supplying a stepper motor with alternating current is the impossibility of changing the speed rotation, which is set by generator frequency. In our case it is 16 Hz. As we can see, the rotation is very fast, which will affect on the propeller pitch speed. Before installing the driver, I did a test of overheating of the circuit, where I monitored the temperature using a thermal imager. Driver installed in the switchboard, and now in emergency mode from the engine control room using the ahead-astern push buttons, we will change the pitch. If we keep the button pressed, we see a very fast pitch changing. This is not good, but if we press the push button impulsively, as a result pitch will change with short steps. Now the crew can use the system in emergency mode. Go up to the wheelhouse to test the system. Emergency mode activated. Press the buttons and see how the pitch changes. Now we need to figure out why the system does not work in follow-up mode from lever. Alarm CPP control failure still present. How can we see from the diagram that the wires from the switchboard where the stepper motor driver is installed go to the control panel switchboard with electronic control boards and the micro terminal for system diagnostics. This electronic switchboard mounted near engine control room, 2 upper ones for stern thrusters, 2 lower ones for main thrusters CPP. Open the door and see an error on the micro terminal DP pitch order. Then we will get acquainted with the manual in order to better understand what important parts the system consists of, how to properly work with microterminal, how to check readings using test points, and also with microterminal we can readjust the system, check the signal of current, voltage, frequency. And all these features facilitate troubleshooting, but in the stand and aft thrusters electronic switchboard microterminal not provided. This sheet describes about DP pitch order error. Plus minus 10 volts signal must be present at the analog input 2. If the voltage value is outside these limits, the system generates DP pitch order error. Press F3 and number 2 in order to check input value. 11.9 voltage indicates the value is out of range limit. Check this value with multimeter on 175 and 6 terminals. Now we need to find out where this control signal comes from. This manual has no information about further electrical connection with CPP maneuvering lever. According to my supposition, the system has electronic signal converter, and now it remains to find it. The required information was found in NOR Control Automation System manual. It helped me to understand how the propulsion control system works. Also, this manual has a block diagram of all control panels. Controllable pitch propeller, electronic control unit with microterminal, control panel in engine control room. It receives pitch signal from maneuvering lever, aft thrusters and bow thrusters. Let's look at the electrical diagram of maneuvering lever. Emergency mode push button and for pitch increasing ahead astern push buttons. And finally an important element of the system. This is a 4-wire potentiometer that gives a signal of 10 volts of different polarity. On the next page in this manual we see signal converter. There are 12 converters in the system, 6 of them for each stern, bow, main thrusters, and the rest 6 in order to transmit signals from DP computers. Now we need to find and check the converter that is responsible for the faulty thruster. The location of converters is not specified in the manual, but it was not difficult to find it. They are installed in the center consoles, on the navigation bridge and engine control room consoles under the double maneuvering levers. Replace the converter, then acknowledge the CPP control failure alarm and proceed to test the system with my alternating stepper motor driver, testing two main thrusters simultaneously to see the time difference between factory DC stepper motor driver and my AC driver. System works smoothly due to feedback potentiometers. While testing the system, we found an incomprehensible behavior of the system. Apparently, the signal from potentiometer in the lever is lost and the arrow tends to return to zero. After a couple of lever manipulation, the system started working, but the next day in the process of testing the problem returned. Set the lever to the ahead and see the arrow goes to the astern. Set the astern position and the arrow goes to astern 2. The problem is obvious, the 4-wire potentiometer is out of order. It is not available in spare parts now, but it can be removed from the unused panel on the wheelhouse. And today my assistant was second officer. The potentiometer was tested before dismantling and installed under the supervision of second engineer.
Мы рабы, товарищи электронов. Вот такое. Подчиняемся его приказам.
Так, сейчас, давай надо снять эту тему.
Да, я буду снимать.
Adjusting the potentiometer took a little time, and as a result the system worked properly. 2 months later we received spare parts and a new driver was installed on its original place. Also at the beginning of this contract, one bow thruster and one stern thruster were faulty. The problem was also in signal converters. After replacing them, everything worked properly. Thank you very much for watching the video to the end. Subscribe to my channel, leave comments. In these difficult times of my country, your support is very important.